Now, let me just say that for a long time, I was completely on board with Antonio Zamora's hypothesis that the Carolina Bays were formed at the Younger Dryas boundary. The Younger Dryas impact hypothesis is a very popular idea right now, and it's been collecting a lot of steam. The Comet Research Group has been doing some fantastic work that suggests that there was definitely some form of a cosmic impact event that ended the Pleistocene and began the Holocene right at the Younger Dryas boundary. And I absolutely thought that the Carolina Bays could have been part of that event. And Antonio Zamora, presents some really good quality work that suggests that they are indeed part of this event. On the other hand, as I mentioned in some of my previous videos, Michael Davies and Tim Harris have quite a bit of evidence on their side of the aisle that suggests that this is a mid-Pleistocene event, that the Carolina Bays were formed somewhere around 786,000 years ago. And I already mentioned the story about Tim Harris staying at the house and us having discussions about Carolina Bays and the Australian Asian tektites, the AA tektites. But that's not what convinced me that there may be more to this story of the Carolina Bays and when they formed. It was actually a conversation that I had with Michael Davies that kind of made me rethink a few things and kind of put me on this path that I'm currently going down with these Carolina Bays. And we were discussing how these Carolina Bays are formed in very flat terrain that stretches pretty much the entire extent of the coastal plain. And he used the term that the coastal plain is almost pool table flat, and it's one of the reasons why he uses the colorized LiDAR to show where these Carolina Bays are, because without it, it's very difficult to see, even on the ground. There's people that live within Carolina Bays that have no idea that they're living inside these Carolina Bays. And so he used that term that the coastal plain is pool table flat all the way to the coastline. And that made me think that that's not quite accurate. Now, here on the coast, we have barrier islands, and that's today. That's during this current, late Pleistocene time frame. But we also have sand hills, which are ancient barrier islands from when sea levels were much higher than they are today. And so when Michael Davies said that the coastal plain was pool table flat all the way across, I was like, well, no, it's really not, because we have these sand hills. We have these ancient barrier islands that were formed during older timelines in the Pleistocene, and they're commonly referred to as Paleo-Atlantic shorelines. Again, these are shorelines that during the last time the sea levels were higher than today, we had the same exact coastal processes taking place. We had barrier islands, we had the estuaries behind them, all the things that we see today, just at an older time frame. The sea levels go out, and now you're left with this hill of sand that even takes the shape of some of these barrier islands. And so to prove him wrong, I went to his LiDAR and pulled up some images very similar to what's above right here, that show where these sand hills are, to show where these ancient barrier islands are. And what I saw kind of made my stomach drop a little bit. That feeling you get when you're like, oh my gosh, I've been like maybe really, really wrong. Nobody likes to be wrong. And so what I noticed was that on those sand hills, on those ancient barrier islands, all those red dots up there represent Carolina Bays. But all of the locations under that elevation, all of those locations between that ancient barrier island and where the sea level is today, is missing Carolina Bays. They're completely gone. They're not there. So what does that mean? What does that mean? Where did I take it from there? Well, I did what any good scientist would do, and that is go back to the drawing board. Again, this is a time where I really had to focus on where this evidence was taking me, and because keep in mind that if this occurred at the Younger Dryas boundary like I originally thought, then we should see Carolina bays all the way to the current coastline, because 12,000 years ago, sea levels were a lot farther away than they are today. Sea levels, the last time sea levels rose higher than they are today was 125,000 years ago. That's much older than the Younger Dryas. And so again, at that time, at the Younger Dryas time frame, sea levels were a couple hundred miles away from our current shoreline, and they were a few hundred feet lower than they are today. It's about 100 miles out, and about 300 or 400 feet lower than they are today. And so where are they? If they're not there, then where are they? And that's where this Carolina bays, where do they come from and where did they go, came from, because something happened to them. If there were Carolina bays at the Younger Dryas all the way to our current coastline, they should still be there today, and they're not. Where did they go? So what I did then was look up our current ice core data from both Greenland and Antarctica, and try to figure out exactly when the last couple times sea levels were higher than they are today. This is fairly new science. We didn't always have ice core data to tell us these things. I know that if you go into some of the literature, they have different time frames within the late Pleistocene where sea levels could have risen, but the ice core data suggests that that's not true. That the last time sea levels were higher than they are today was 125,000 years ago. That's the Eemian time period, and sea levels went up and down before that. And the last time that sea levels were higher than they were then during the Eemian was around 400,000 years ago. And I think that there's evidence that suggests that both of those interglacial periods may have erased Carolina bays from their original location. And so that sets them way back. And not only does it set it way back, but it puts it into that time frame that Michael Davies and Tim Harris suggested as a mid-Pleistocene event. And so in the next video or two, I'm going to look into this a little bit closer, show you a couple examples of what I'm talking about. But again, this is one of those things that when I saw it, my stomach dropped, and I had to, I had to admit to myself that, science is not a popularity contest, and sometimes you have to go where the evidence takes you. And in this case, it very well could mean that the Carolina bays are much older than the Younger Dryas. Now, are they exactly mid-Pleistocene in age? That's time will tell, but I can say with certainty that it's looking like they are older than the Younger Dryas. Now, there is a chance that Antonio Zamora can come up with some better evidence than the Paleo-Atlantic Shorelines to prove that the Carolina bays are part of the Younger Dryas. But right now, again, I've got to go where the evidence is taking me, and that is taking me into a much farther time frame. And we'll see where we go from there. We'll look at a couple examples next time. All right, bye.